Yeah. Friends, can you please confirm if I'm audible? Wonderful. Okay, let me share my screen. Thank you for the confirmation. Friends, just wanted to set the context. I'm actually traveling, so I'm in a location where the internet connectivity is not up to the mark. So I just request you people to let me know if there is any problem in my audio. All right, and let me share my screen. There you go. All right, let's begin the session for the day, friends. Once again, good afternoon and good evening, based on the location where you are connecting to the session. Hope you all are doing good. And let's begin the session. All right. So text mining and NLP. The most happening topics in the world of analytics. If you talk about AI, then NLP would be one of the most popular topics that you might want to focus on. Now, as part of today's session, today and tomorrow, we are going to deep dive into certain concepts of dealing with text data, the algorithms, the techniques, which become the foundational concepts for us to process this text data. The first thing you need to understand is why is it so important for us to look into processing of the text data? Right? What are the benefits, or why in the first place we have to look into processing of the text data? Now, if you look into the history, right, 1980s, 1990s, when the world was not as digitalized as we speak today, majority of the data that was generated was in manual form, right? The world was not digitalized to a certain level, at least to the level that we are today, right? We are at. So manual data was generated a lot. And for processing of this data, we used to have very limited resources. Later on, when the industry started to become a little digitalized, to look into their data, they started procuring softwares which can allow the organizations to store or archive data so that it can be processed for better insights or better information extraction. These softwares are nothing but databases. Now, when we talk about these databases, it all started with RDBMS software, which allow us to quickly retrieve and process the data, humongous amount of data that is getting generated for industries. But when you speak about RDBMS systems, the softwares, the traditional systems, they are capable to only deal with table data. Table is basically nothing but structure. I'm speaking about structured data, which is represented in table format. That means you need to have a predefined definition, blueprint for your data which is getting stored in rows and columns form. Unless until it is arranged in this form, you will not be able to process it. You will not be able to access it. Indexing needs to be done. This is where we introduce a word called schema. Schema is nothing but the definition of the fields that are getting uploaded into this particular table. So in these times, right, in those times I should rather say, the data that was getting stored was in structured format. And anything like description, right, all those textual data, which is one of the first types of unstructured data, could not be stored. Okay. But in early 2000s, the entire dynamics of the industry changed. Why? Because social media started penetrating into everybody's life. Right? In early and mid 2000s, social media invention happened. Facebook, to name one. Now, if you look into the Facebook, right, from a Facebook perspective, right, from this organization perspective, how is the data looking like? Right? What data does Facebook have? To start with, you may say that customer details. Facebook customers are we. Everyone who has account in Facebook is a customer to Facebook. So customer details will be there. Now customer details can be recorded in table format, no problem. But what about the customer transactions? When I say transactions of customers in Facebook, we are speaking about the posts that we do. What are the various types of posts we are doing? We write messages. We post videos. Messages is nothing but text. Videos, images, emoticons or GIFs, right? So on and so forth. Predominantly, these are the things that we can see the data in Facebook. Now, this information has to be stored because for a Facebook to make money, it has to personalize the customer's behavior, individual's behavior. So they need to archive all these details of individual people who are using Facebook for doing communication. So how do you archive is the question. Now, because this data is unstructured in nature, archiving requires special softwares, and that is where we have NoSQL databases and right, big data solutions. These things came into picture. But we are able to store this unstructured data. Now, as part of today's scope, we will focus only on text part of this unstructured data. Now, what all things we can do is a $1 million question, right? Using this customer's behavior on social media, individuals, customers are nothing but individuals. Based on the individual's postings, we can understand what kind of a person or what kind of interest that person has, right? And this information can be used for customized marketing. And Facebook is using this information for making money, not small money. They make big money, right? Billions of dollars. Because if you are a business owner and if you're manufacturing a product or you have a service to offer, you need end customers, clients. But where do you find them? Right? So you have to try and market your product. But in order to identify who's your potential customer, we can look into Facebook's details, individuals' details, and that can tell us who are your core, right? Customers or customers of interest. What is the segment of your customers? You would be able to target that particular segment alone. So Facebook will take money to give you that information and give you the details about those customers. And this is how you'll see a lot of ads coming in, right? On Facebook, you see a lot of ads. That is based on all this strategy that we just discussed. This is just one example, friends. Small example. There are limitless applications that can be done. The entire world is, right, getting affected, still getting affected, right? Hundreds and thousands of people died because of COVID-19. But there is one organization which upfront predicted that there will be a pandemic in December 2019, even before the pandemic, right, taken the entire world by storm. This one organization, which is a Canada-based organization, they have scraped through the data, text data, which is populated across the world, right? They have scraped that data, and when they analyzed, they identified that there could be a pandemic which would affect the entire humankind, right? Mankind, or human world. So human species is getting affected is something which is predicted upfront. Now that is something that we should have actually consumed in a much proper way, because the information was readily available. It's just that we humans gave a blind eye to this information. But if you would have considered this information, then we would have saved a lot of people. You would have quarantined, right, implemented the quarantine policies more strictly, and we would have saved a lot of people. So on and so forth. These are all the examples, right? So what we are basically trying to understand here is to deal with text data. Because in today's world, majority of the data that is getting generated is in unstructured form, and one of that unstructured form which is more popular is text data. So these are few of the concepts that we are going to learn. As I mentioned, structured and unstructured data. Majority of the data that we are seeing is unstructured in nature. And you already know all this stuff. There are some of the examples which are populated here. Call transcripts, when you make calls to customer care executives and all that. Emails that you send to the customer service. Social media, that is what we discussed. Speech transcripts, thanks to news channels, media houses, right? Media houses, they give us true translations of these speech transcripts. They convert. If some important person, VIP, is giving a speech, then that entire information can be automatically converted to text form. Field agents, salespeople, or surveyors, right? we collect a lot of primary data. This primary data would be very, very important in making business decisions. Right? This gives us the most relevant information that we need for processing a certain business scenario. And all this data is generally in unstructured nature. Survey. Ask a question and you accept in a more naive way, right? Like a paragraph. Of course, conducting surveys is also an art, and we need to have the survey questions which are measurable. So we will try to frame the question which can be measured on a scale. So we are converting that unstructured data into structured format. For example, rather than asking, do you like this session? Do you like the NLP session? Rather than asking this question, which is an open-ended question, we ask, rate the NLP session. This is a close-ended session and you're giving options to the potential customer who is going to fill this survey to choose one among these 1 to 5 options. Now, when the customer is choosing one of these options, the value is now measurable. So, conducting surveys always, right, is basically inclined towards having survey questions which are measurable. You cannot have open-ended questions. This is one important point that you have to remember, especially when you're trying to collect primary data for your analysis. Quantifiable values. But there will be certain scenarios, for example, Amazon. In Amazon, you have average rating. Rating is a quantifiable or a measurable value. But if you also look into the reviews, customers' feedback, this is open-ended. It could be anything. We don't know. Customer can write any review. Right? Now, how do we process this kind of information is what we have to learn. And there are these various examples or various use cases or benefits that the analysis of text data provides us. Let's say there is a phone, mobile phone which got launched. The manufacturer wants to know the feedback from the customers about the phone. What are the features which customers like? What are the features which customers do not like? Do customers have any suggestions? Right? So various emotions have to be captured. That can be done when you capture the review that is provided by the customers. Now, we are not talking about one single review. We will have multiple customers who are providing their review. We have to accumulate all that text data, and then we have to process the text data to understand what are the features which the customers are speaking about, or what are the features that the customers like or dislike. We can also extract meaningful information from the unstructured text data. For example, say Amazon phone feedback. Now, in this information, let's say we are speaking about one specific, let's say, date. There was a humongous offer that was given. So you will be able to identify this date. Right? Maybe the phone was marketed by a VVIP. Okay, manufacturers have backed in a VVIP, probably a movie star or a cricket star in India, who come up and give some ad on the phone. And in that ad, probably there are certain features which are highlighted. Now, customers, when they use the phone or the product, they felt that the features which were highlighted in the ad were not up to the mark, right? And customers might vent out this particular frustration in the reviews. They invested on the product based on the ad. So now they want to mention some feedback about the features, about the ad, right, etc. So you would want, as a manufacturer, you would want to know happy or what is that specific feature which customers are very happy about, right? Which date the offer was released, which variant of the product is very good, or maybe in different countries there are different versions of products released. In which country the product is not doing good, in which country the product is doing very good. You want to extract all this information. That information can be done, or that can be extracted from reviews. Now, the country names, the date, the features, right? All these are named entities. We call it as named entities. So we have named entity recognition algorithm as well, which will allow us to extract structured information from unstructured huge reviews data, right? So that is another benefit. Various other things can be done. Topics and themes can be extracted. Sentiments can be extracted. Recommendations can be done. Of named entity, location, companies, right, etc. All these things can be done, including phone numbers and other important information. One such example, one more example that I'm quoting here. There's a lot of research happened with respect to COVID-19. Right? Very, very humongous amount of research has happened recently in the last 2 years, 2020 and 2021. Now, all this research work was published by various research scholars, right, in PDF formats. Various journals were consulted and the research work was published. But this research work would be in, right, we call it as unstructured format. Now, what we did is extracted meaningful information out of all this data. There are thousands and thousands and thousands, 10,000s, right? Huge number of articles which were published. Now, out of all that published articles, what is the name, or let's say, I would say, what is the primary problem that was addressed? Right? What drugs were predominantly used? In which location there was more aggressive testing? In which location aggressive testing was not there? Right? What are the, let's say, names of the organizations or the doctors who are actually involved in conducting this research? So on and so forth, etc., etc. All these entities we were able to extract, including dates. When was the publish conducted, right? I mean, when was the research conducted and published the paper? So dates can also be captured, and we captured all this and arranged in a structured form, right? So if I have 10,000 reviews, or I should say feedback of your research paper, reading or going through all the research papers may not be easy. But if I can have the structured arrangement of all these 10,000s of research work in this table representation, then extracting information becomes easy. So this is named entity recognition, friends. Now, before we proceed, we have to remember the terminologies. The entire raw data is known as corpus, and this corpus is made out of individual document. Collection of documents is nothing but corpus. These are the terminologies that you have to remember. And in order to extract information from unstructured data, we have to first structureize. We need to structureize it so that the computer can understand that particular data. Now, as part of this step, we do pre-processing. We do pre-processing of the data, text data, and then we gather tokens. There's a process called as tokenization, which is the default step. The tokens are nothing but the keywords. Tokens are nothing but the keywords. Now, once we have tokens, then we can process that information. We can process the information from this tokens. Right? But what kind of pre-processing would you do? What various challenges we might encounter? Those things we have to look at. And in order to do this pre-processing, you need to first understand the language itself. There are a lot of packages. One of the default packages is NLTK package, Natural Language Toolkit. Okay, we will look into NLTK package also. There are various other packages that can be used, including Keras also we can do the processing. There is something called as Spacey. Under this Spacey, we also have Displacey. Displacey is for visualization, Spacey is for textual data manipulation. Now, all these libraries are pretty much applied on Python software, Python programming. And we have to remember that Python programming is the programming language that we have to look out for. For unstructured data processing, okay, All right. Hope my voice is okay now. All right. In the world of data analytics or data science, there are two important programming languages which are very, very popular. One is R programming, the other one is Python programming. Right? Now, R is a programming language which is a single threaded, whereas this is multi-threaded. Okay. And because of these reasons, R has various challenges, of course, when compared to Python. But R is the go-to tool or go-to programming language for data analysis, for structured data, or for machine learning implementations. But Python is more a generic programming language, right? It's a generalized programming language, and it gives us a lot of flexibility when dealing with unstructured data. So what I'm trying to explain here is, for analyzing your text data, Python would be a better option than R programming. We will also focus more on Python programming here, but of course R will also be something that I will explain. So this is about the pre-processing step at a high level. We need to look at text data, right? And we have to clean it. After cleaning, we have to structurize it, and then we process it. So these are the steps that you have to follow for textual data at a high level. There are various things that will come into picture. We will try and understand all that. And ultimately, what we are doing is, after cleaning the data, this unstructured data, it could be any text message. It could be customer. It could be a customer review. It could be employee feedback. It could be, let's say, some kind of a VVIP speech, right? Or a novel, etc., etc. Or it could also be a business journal or legal document. What we are trying to do is clean this particular data and convert this data into structured format, like this. Right? And this structured data, once it is obtained, then processing it becomes easy. And there are various things that we can do on structured data. Now, when we are trying to process the text data, very important information that we need to look out for is the context. A computer, which is basically a non-living thing, has to interpret the context as well when it is processing, or when they are trying to look into text data. Then we should not look at the text data just as the keywords, right? Because each keyword may have different meaning. So context is something that we also have to look out for. If you directly go with these keywords, then you're basically saying that it is language models, default language models, which do not have good accuracies, which will not be able to solve a lot of problems. Right? That is where we go for enhanced methods, which are called as natural language processing techniques, NLP techniques. As the name says, natural language processing. Just like how humans understand the language in a natural sense, the same way we are expecting the computer, the machine also to understand it. Hence the name NL. Excuse me. Text analytics, right? Textual data analysis, by definition, is known as extracting meaningful insights and answering questions based on the textual data. Can I try and answer business problems? Can I try and extract the actual context or actual meaning of the text data that is updated? This is the actual definition of textual analytics. And this text analytics, as we discussed, is to process the text data in a most natural form. And this is where we introduce ourselves to NLP, natural language processing. But this NLP is further classified into NLU and NLG. What does NLU means and what does NLG means? The NLU is known as natural language understanding. That means when you human are speaking or giving text data to your computer, to your bot. Let's say there's a human being here, and human being is making communication with a computer. Okay, with a computer. So if the computer understands what the human is saying and then follows the instructions, performs the instructions, then this is called as natural language understanding concept. You can say it is a one-way communication. Okay? It's a one-way communication. A process by which an inanimate object, a computer, or basically a machine, or a robot, performing actions based on the inputs that we humans give. Right? That is your NLU, like voice activated devices. How many of you use this Netflix take or Airtel take or Geo? Very simple example. You speak to it and it performs the action. This is NLU concept. Then we have NLG. Not just understanding, but the text data has to be generated also. This is called as NLG. And this NLG is a two-way communication. Here it is always a one-way, whereas NLG has two-way communication. Best examples are generative chatbots, voice-activated chatbots. When you speak to it, it understands and then gives you another response. Right? So that is your NLG. So your NLP, natural language processing of text data, can be further classified into NLU and NLG. And when we speak about text data or NLP, speech is also something that we need to consider. That is also a form of unstructured data. Right? Exactly. Alexa, iPhone, Apple, Siri, right? Windows, Cortana, all these are examples of NLG. They just don't take the instructions, but they also respond. Now, implementing these solutions will have many benefits, as I explained. Trivial questions can be answered. For example, if you're going to a bank, right? The front office executive, help me board, will be there. And customers, whoever is walking into the bank, they go to that front office, front desk, inquiry, and they keep asking these people will address, will be repetitive. Right? Physically, a person sitting in the front office, right? Now that office is nothing but the bank's website, and the front office is nothing but the chatbot. You don't feedback mechanism will also be there, right? Wherein if there is a question which chatbot is not understanding, oh, okay. I think my internet is still fluctuating. Yeah, is it okay now? Or is it okay now? Am I audible? How is the audio now, friends? Can you please confirm? Okay. Yeah, friends, as I mentioned, I'm still traveling. So, yeah, you have to please bear with me on that. Thank you, friends. Thank you. Okay, let me bring back that example. So we were speaking about the bank example, right? So all these days, we used to go to bank, physically visit the bank, right? And the front office, front desk is one of those divisions in the bank which is very, very, very busy. Because any customer who's walking into the bank will make an inquiry, right? They'll ask questions. Now, the front desk, the people who are sitting in this, they need to have the information right? And they need to give the information to the customers based on the questions that they are receiving. Now, lockdown happened, right? I mean, we are living in lockdown now. Slowly, people are coming out, but still it is risky. So in the lockdown, physically, there was not possible to go to banks. Physically, visiting is not possible, right? So what did we do? We went on to visit the website. Now on the website, you can say website is like the physical location, bank. And on the website, we have now chatbots. These chatbots are like your front desk, front office, right? But again, the problem is you need to have a human being deployed to take in the questions and respond. It's like your chat, like you speak with your friends, right? Now, how about automating this so that without any human intervention, when a customer is asking a question, the system should understand what is that question and then respond to that question in an appropriate way. This is the idea which triggered chatbots, and there are various different techniques that are used for chatbots. Initially, the chatbots were rule-based. That means if you have a question, and this question will have an answer predefined, and if customer is asking the question in the same way, this answer will be given. But communication is very dynamic, right? Communicating things are very dynamic. People have different literature, different ways to express their express themselves. So confining to a specific question is not practically viable. For example, you will say, is Friday a working day? Right? This is a question. We are asking something based on Friday. So is Friday a working day? That's one question. Do you have off on Friday? Is bank closed on Friday? So many different ways to pose this question will be there, right? The context of the question is same, but the way we ask may vary. Now, if you're trying to automate things, then your computer should be able to address this answer. They address the question in the natural way, like how we humans understand, interpret the text data, the question, and respond to it. Same way, the computer has to do it. So, rule-based chatbots, dialogue flow-based chatbots are not something that we have to confine with. Evaluation for everything there will be evaluation, research happens, and we tend to improve the solutions. So we have something called as generative chatbots now. Generative chatbots are more dynamic based on the query. The chatbot will look into that context of the question and tries to find the answer in a more appropriate, right? So that is something which is defined by NLP, which would understand the context. This is an example of NLG, natural language generation. You don't just understand the question, but the expectation is that understand what is the context and you generate the answer also. If the answer is not there, you generate it as well. So you have NLU, one-way communication, NLG, two-way communication. In other simple ways, if I have to put it, very simple example, is Friday a working day? This is a question, natural language understanding. I'm talking about a chatbot only. If the chatbot is enabled only with NLU features, then it says, no, it is a working day. This could be an answer. I mean, just an example. So we are looking at the question and we're saying, no, Friday is a working day is the answer. Now, if you say NLG, right? For the same question, there may be a prompt saying, which Friday are you asking for? So it needs to understand the context of this question before it can answer it. Right? So there could be a follow-up question which is which Friday. Then probably the user again has to clarify on which Friday, right? The user is basically checking for. And based on that, the final answer could be given. Right? So these are the examples for NLU and now I'm pretty sure everybody remembers the CRISP DM methodology. When you talk about CRISP DM methodology, we understood that data pre-processing is the most time-consuming task. And it is very dynamic. It requires a lot of things to be looked into based on the business and based on the data that we are trying to look into, business problem and the data. Based on these two conditions, the data processing needs to be performed. Now, when we talk about text data, we need to look at to the text data into structured form. Right? Any text processing algorithm that we need language that you is it okay now? Is it still not okay? It is okay. Yeah, I think the internet is fluctuating, and whenever it is going down, we are having the problem. Yeah, I request you people to please be a little patient with me. Unfortunately, suddenly I had to travel, so it's unplanned. Yeah, please request you to please bear with me on that. Okay, so let us talk about data pre-processing again. Let me repeat. For any analysis, data analysis task that you are doing, any business problem that you are solving, any kind of data that you are doing, the most time consuming step is the data pre-processing, which is the third step of your CRISP DM, right? CRISP DM methodology. Right? Now, as part of the text data also, when you are trying to analyze the text data also needs to be cleaned, pre-processed, right? And the first and foremost thing we need to look at with text data is that it is unstructured. So we have to try and make sure the data becomes in structured format. It converts to structured format. If the data becomes structured, then performing analysis on that data becomes easy for your computer. And when we talk about any language, text to data, right? It is nothing but language. The language is made out of words, right? Your text to data is made out of words. So when you get the text to data, we need to get the words first. And this process is called as tokenization. And this becomes the most important step, the foundation step for processing your data. Tokenization is a terminology which is referring to splitting data into words. Now, when we think about English or English-like languages, majority of those languages, which are English type, we have one benefit with English or the similar type of languages is that the words are separated by space, right? We call English-like languages or English language as space delimiter language, space delimited, right? You can see this is an English language. Tokenization space refers space to space D. So every word is separated by space. This is the standard format or form of how text data is written. So splitting of these words based on this logic is called as tokenization. Each word is referred to as a token. Each word is called as a token. And when we are trying to process the data, we can perform tokenization to capture single word. Like this is one word, this is one word, this is one word, this is one word, so on and so forth. Or you can take two words together. If you take two words together, you're basically referring to this as one set of words, this as one set of words, this as one set of the words, right? This as one set of the words, and this as one set of the words, so on and so forth. Yeah, friends, am I audible now? No, no voice? Audible, right? Okay. Yeah, so friends, I'm requesting once again, because of my sudden plan, which happened a couple of days back, I am in a location where the signal, the internet is not good, 100% good. So I'm trying to have some fixes here to make sure that the learning does not stop. So whenever you see that the audio is not clear or it is going down, you immediately raise the concern. I'll repeat that part. I know it is frustrating, but please be right. Please be with me here. I'm trying to find some alternative solutions. Let us resume. I was talking about tokenization here. Tokenization is a process of splitting the data into keywords. And because English and majority of other languages that we have, these languages, or for example, we only stick to English for now, is space delimited language. That means each word is separated by a space. And when we are trying to tokenize, we can try and tokenize using this concept, right? Space concept. We can try and tokenize a single word, or we can take two words together, or we can take three words together, or so on and so forth. You can come up with n-gram tokens. N can be 1 or 5 or 10 also. Okay. But there will be certain challenges also. When you do pre-processing, it will not give us a complete solution. It is not a foolproof. There will be challenges like this. We have an office in United Arab Emirates. Now, when you do unigram, that means we are taking one word at a time. We have V separated, have separated, and separated office in United Arab Emirates. Each word is separated, especially when there is a space. But if you look at this statement, United Arab Emirates have to be taken as a single word. That's the name of a country, right? So if you take unigram, then this will be a problem, right? So we have to look out for best possible solution based on the data that we are dealing with. And practically, we try out with unigram, we try out with bigram, and maximum is trigram. Because when we are trying to look into the text data, one word, yes, there's no problem at all. We can see n number of different words. Two words repeated together. So you can say not, you can say good. This is unigram. If you say bigram, then it will be not good. Right? Like this. But three words if you are talking about, then how many such three words sets will be there, which are frequently used? We are talking about frequently used words, okay? United Arab Emirates, very good. That is one word, basically set where three words are used together. But how many such three words set would be there? When you compare with one word set, two word sets will be limited, a little less. 3 words set will be very, very less. Can you come up with a 4 set word? 4 words set? Can we imagine a 4 sets word? Not many, right? No, right? Yes. So practically also we restrict ourselves only till 3 words set. Okay. This is something that you have to remember. Next, this is one such step which is, I should say, mandatory step for processing text data, tokenization, which is nothing but splitting of the sentences into words. Then, POS tagging. POS tagging means parts of speech tagging. Or you can also call it as grammatical tagging of words. This is like labeling the word. Now, based on this parts of speech tagging, the context of the sentence can be easily understood. This is something that we learned in English grammar in our childhood days. People who are coming from, let's say, English literature side of study, they would be very easily understanding, right, these parts of speech tagging advanced concepts. But for our basic understanding, you can remember, very well remember verbs, nouns, adjectives, right, pronouns. Those are nothing but your parts of speech tagging, or it is also called as grammatical tagging. Parts of speech tagging post. These are some of the examples. N and S noun, plural. NNP, proper noun, singular, proper noun, right? Plural proper noun, adjectives, adverbs, verbs. So many different things are there. I'll show you the list also. These Python codes are there. You can also experiment. These codes are given for students who have enrolled for the program, and majority of you already have the codes. You can look into that code. I'll also show you. There will be a big list of these NLP and POS tagging list. Next is, as part of the pre-processing, you also have to look out for removal of unwanted stuff. Pre-processing also means cleaning. Right? It also means cleaning. Okay. Am I not audible, friends? I got a message. Can others confirm? Am I audible or not? Okay. No voice? Audible? Oh, okay. Oh, so internet issues are there on the other side also. Okay. Okay. Thank you, guys. All right. So stop word removal is one of another essential steps that we have to do. Basically, this, if you have to generalize this step, it talks about cleaning of unwanted content from the text data that we are trying to process. We will have a predefined set of words as stop words. For example, if I go back to this statement, we're talking about tokenization refers to the process of splitting a sentence into its constituent words. So here, the word to is a stop word. The word the is a stop word. Of, a, into, its. Now these are certain set of words which are frequently used. Apurva, others are able to hear Apurva. I think there is some problem from your side as well. Please check that. Others are able to hear me. All right. So these are certain set of words which are frequently used. Right? Now we have to clean these kind of words which are frequently used because the context, right, will not be interpreted in these words. It does not give you any meaning of the context, right? So we have to clean that. Now, it can also be a custom set of words. When you are trying to analyze certain text data, you may define certain set of keywords or words or tokens as unwanted words. So you can create custom dictionary and remove them. But in Python or in R programming, there will be certain set of predefined stop words which can be used. Okay, it depends on what tool we are and what libraries we are using. Internally, these set of words are predefined. Next is normalization. Text normalization. Now this concept, you can see here, Gurgaon and Gurugram. This is a location. United Kingdom and UK. This is a country. Malay versus Bhasa. This is a language, right? Now, all these words are different. Text-wise, they are different. They're pronounced differently, right? They're, I mean, you can see the spelling is different. But one thing is common, that is the meaning of these words, right? The definition of these words are common. So if you're looking into a text data which is basically having all these different forms, then the interpretation of these words will become difficult. So we need to look out for this text normalization step, which basically says that we have to convert all the different forms of words into a standard form and then make the interpretation. For example, we speak about, let's say, Malaysia. I've frequently visited to Malaysia, so I might be writing some text data, some context, probably my experience in Malaysia. So I have written a very big passage. Okay. Now in that passage, I might have referred to the language as Malay. Somewhere I might have referred to the check the connection, friends.
Yeah, it looks like there's some webinar jam issue. Just connecting. Not able to show my screen. Yeah, some webinar jam issue. Just trying to figure that out. It's not internet issue. Are you able to see my screen? No, right? Yeah, it should be okay now. Not screen, right? Okay. Give me a second, huh? Yeah, friends, is the screen screen is also not visible, is it? Wise. Friends, is my screen visible now? Can you please confirm? Okay, the screen is also clear, right? Okay. There was some issue with the webinar jam. I just had to re-log in. Okay. Yeah. Little. Yeah, but I think little unplanned issues. All right, so let us resume. We were discussing about text normalization, where we have different words which are spelt, pronounced, and represented differently. But for all these words, the meaning is same, right? So if your computer, if your machine has to interpret these words, right? Machine Hey guys, am I audible now? I'm just checking if I'm audible. Then yeah, just keeping you informed that I'm checking with the team to reschedule this. Okay, just yeah, disturbance is there. That is the reason I'm just checking if we can postpone this session. Okay, so just give me another couple of minutes, and I'll give you the right information. I know, it is very important. Topic, and that's the reason why we have had this session. But say it's unplanned. I had to travel, and right, and these challenges are correct. Yeah, please be with me for another couple of minutes. I'll confirm. I can try like this, but again, it will be very frustrating for you all. Okay, friends, am I audible? Screen is visible, is it? Okay. Am I clear now? Is it audible, friends? Okay. Okay. Let's try for a couple of minutes to continue. In the meantime, I'll also get some confirmation. So rather than just waiting, let me start explaining the next point. Okay. Yeah. Okay. So we were discussing about text normalization. Let me share my screen and then start. Okay. I hope my screen is visible. Yeah, I'm in terrace, Murari. Actually, I'm sitting in terrace. So you will see, you will hear birds and you'll hear all sort of noises as well. This is only for temporary, just for a couple of minutes before I get some confirmation. Okay, yeah. All right. So text normalization, we are trying to understand this part, which basically says, if you have different types of words, right? We basically have different words, which may have same meaning. Now, in such cases, we will have to try and bring in the same standard form for all those repetitions, right? So if I have Malay and Basa, for example, I was giving an example of, let's say I'm writing my experiences, right, of visit to Malaysia, MY. So as part of that experience, right, I wanted to share my journey to Malaysia, what various things I experienced there and all that. So maybe in one such passage, I have mentioned about the language there, and probably I mentioned the word Malay. But the same language is also known as Basa. So probably after some time in some other passage, I have used this word. From the context perspective, my intention was to represent the language which is used in Malaysia. But the words are different, they are spelt different, right? Dictionary wise also the word is completely different. But meaning is same. So for interpretation, extraction of information, if I have to do, right? Extraction of some meaningful information, then having the word in the same standard form would make more sense. So text normalization is a concept of converting all these different forms to a standard form, right? So there are packages which allow us to do this. Next, we also have various other things to be done on text data. For example, here you see spelling correction. There is a very interesting topic called stemming, and on top of stemming, we have something called as lemmatization. So let us try and understand that. To start with, spelling corrections is a very trivial problem that we see in text-related challenges. Right? One of the important tasks, any text data that you are talking about, any text data, we will always have typos. And this is something which has to be handled, because your computer would not understand the difference between these typos, right? It will basically give you the same, it will just take the word as is, and it will not talk about the differences between these typos, right? To make sure that we have the right interpretation, first you have to do the spelling corrections. Now you can use third-party packages. In Python, we have a package called autocorrect. Autocorrect. This library is used to do the spell corrections, typos. Okay, we will see examples for all these. Next, another interesting topic. Okay, but before I go to stemming, friends, let me also explain one of the work which is still under research. How many of you use WhatsApp? I'm pretty sure everybody, right? Right? Rather, I should have asked who does not use WhatsApp. Yeah. Now, in WhatsApp, the language that is used for communication is informal language. Right? This informal language does not have a pattern. It's called as informal because it does not have a pattern, right? Now, if you have this informal language to be processed, then you need to try and train your algorithm in such a way that it includes all the vocabulary of this informal language. For example, if you write an email, formal email, you would say, "Hi, how are you? Hope everything is fine," etc., etc., etc. This is how you would use, right, to write in a formal email. If you're doing a message in WhatsApp or Facebook chat or whatever informal social media, you would, sorry, you would basically say something wrong. "Hi, how are you?" Yeah, even shortcut. How are you? Now, when a machine looks into this language, it sees this as a word, or this as a word, this as a single word, right? But do you have any dictionary meaning for this or dictionary meaning for this? No, right? There's no dictionary word defined for this informal words. So your computer cannot process the informal language, and this is where a lot of research is happening right now. It falls under NLP, unsolved problems, right? A lot of research is happening, guys. There is another very trivial problem, which is somebody was asking all about it as well. Abbreviations. In your resume, for example, you say DS. What does DS means? It could be data science, right? It could be daily struggle, isn't it? It could be anything. So a system, there is something called as ATS, automated tracking system. This is the first level of screening mechanism, which is used by a lot of big organizations, MNCs, big pocket organizations or consulting companies. They use ATS system as the first level of screening of your resumes. This ATS system will look into the entire text content of your resume, and it tries to map the content with the job description, JD, job description of the requirement. Now, if your job requirement, job description says DS, and if your resume also has the word DS, then the mapping will be very strong. But in your job description, it is data science, and your resume says DS or vice versa, then the mapping is not strong. In such cases, ATS system will not capture your resume. It will not shortlist your resume. Right? So one interesting fact that you should take a note of here, especially because now you people are trying to apply for jobs, is that always look for job description and then try to adjust your resume to have the keywords which are there in here. Embed these keywords, right? So this is very, very important. And that is the reason I also keep saying, people who interact with me, I say, you need to have multiple versions of resumes. And you need to constantly keep updating it. Okay? Because if there is any change, the system will treat that as a new resume. And new resumes will on the top. So you constantly keep making certain changes in your resume to make sure your resume is at the top of that particular search engine, whatever the system that the organizations are using. And as well, carefully read the job description and use the appropriate keywords. But don't overdo it. Here also you need to make sure that you're not overfitting. Don't just take all the keywords from the job description and put that in your resume. Right? So this is something that you need to be aware of. And make sure you follow these two things for getting shortlisted. Right? So I'm giving you multiple use cases and how we are discussing some point here. This point was related to abbreviations as well as informal language. Because if you try to look at autocorrect, spelling correction, and if you look at informal language or abbreviation, then spelling correction package will not understand that. Right? So you have to be cognizant of these applications as well. These kind of scenarios as well. Then another interesting point that we need to look at is stemming. Stemming is basically splitting of the word. Right? If you have a word like battling, you're splitting the word and removing the successor here, the end part. Right? But the challenge with stemming, which removes the end part, is the word that you are receiving after removing of the end part is something which may not be there in the dictionary. For example, the word battling, if you split the word, ing is removed. But do you have any word called battl in the dictionary? No, right? It's not there. It doesn't exist. But if I actually have to bring in the short form of this word, then it should ideally be battle. Right? So stemming is a process of splitting the word into stem and leaf form. Okay, leaf is the end part. Stem is a word which is repeating. The word which is the main word. Different forms of the word will be there, right? For example, you can say battle, battling, battled. like this. No audio again. Am I not audible? I see a couple of people saying no audio. Am I not audible, friends? We can hear, right? Okay, you can hear. Okay. Okay. Thank you. All right. So battle is a word which needs to be extracted, but this is not a dictionary meaning. So enhanced version of stemming is also there, which is called as lemmatization. In lemmatization, there is an additional check. That is whether the word is a proper word or not, a dictionary word or not. Right? An additional check is done by looking through the dictionary to extract the base form of the word. Here, that base form may not be a dictionary word. Okay, that's the difference between stemming and lemmatization. Now, this lemmatization is, okay, I'll show that again, actually is performed by using a predefined dictionary. If the base form of the word is present in this predefined dictionary, only then this stemming is performed, otherwise the stemming is not performed. That is how lemmatization is achieved. WordNet Lemmatizer is a dictionary which is used. Then we have named entity recognition. Named entities, that means these are already named. For example, people names. These are not definitions, right? I mean, these are already defined. The locations, the organization names, dates, quantities, percentages, all these are named entities. These named entities, sorry, named entities have to be identified from unstructured data. Legal documents, this is another project that we are yet to finish. Certain steps are already done, but this is a very big project that we are working on. There is a legal document, for example. What would be the size of a legal document? Any size, I mean, whatever the legal document that you are familiar with. How many pages would be there in a single legal document? Anyone? It could be property related document, it could be some other case, probably organizations tie-ups. No idea? Legal documents? 1,000 pages? No. No, yeah. Shaker, not really Shaker. Of course, I mean, it would be certain vocabulary would be there. Probably it may not have the entire words that are there in English dictionary. Okay. Yeah. So legal documents, coming back to this discussion, the size of a legal document could be somewhere from 2 pages to 200 pages also. Link documents and etc. 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 There are various things that would come into the picture. A simple non-disclosure agreement is also a legal document, okay? Now, let's say in this legal document, imagine a law firm, okay? An organization which deals with these cases, okay? Has to look at thousands of legal documents. Let's say you're a lawyer, right? You're basically having an office and you're taking in cases. So you'll have multiple cases to handle. Now for each case, let's say there are multiple legal documents, right? Now to keep all this information, remember, from out of these pages, on an average, let's say 10 pages document is there. Like this, you have 10 such documents, assume, or 10 cases, right? Each document is of 10 pages, assume. Would you be able to remember all this information? Not really, right? It's not easy. So structurizing this document was performed, wherein we captured named entities. Parties. What are the parties or people who were binded with these legal documents, legal issues? There will be two parties, right? Party one, party two. The addresses, location, the duration of the issue, isn't it? Etc. 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 Based on the legal issue that we are talking about here, there could be certain information that we can extract and arrange that in a proper format, structured format. So case one, what is party one, what is party two, what is the date of the hearing, when the date when this legal entity was bounded, signed off, what is the duration of the agreement, what location, etc. 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 You can have this named entities extracted like this. For multiple cases, if you do it, you can open this proper small Excel sheet, for example, or your data frame, and you will be able to immediately remember what is the case dealing with. You don't have to go through the entire document again, and even for tracking and remembering things, it will be very easy if you have the structured information. Right? This is one example. I used to work for Oracle Corporation. So, let's say I'm giving a statement here saying, Sharath purchased 300 shares in Oracle Corporation in 2005. What are the named entities in this? Can you people identify? What could be the named entities in this? We are talking about people, places, quantities, percentages, organizations, dates, etc. 300 quantity, name, organization name, date is also a named entity, right? So this way we will be able to extract that named entities, friends. This would be like a summary of the entire text content. This is called as named entity recognition. Then another very complex case is word sense disambiguation. Word sense disambiguation. A word, English is a funny language, right? That is very important to remember. English is a funny language. A word can have multiple meanings. Okay, remember that. This is an example. A word's meaning depends on its association with other words. The context, is deriving the meaning of a word. Two or more words with the same spelling may mean different things, right? This is called as a disambiguation. And we need to try and map the correct meaning to that particular word. For example, he can play multiple music instruments. Dear DJ, please can you play rock music? Another example, Indian cricket team displayed a very good play. Right? India cricket team has displayed a very good play. So for each of this, the word play remains the same. But you see the meaning is different. You can talk about multiple such different words, different contexts, where you can have the same word coming in. Right? So carrying different meanings, and we need to try and map the correct meaning to that particular word. That happens by looking into the entire sentence. All the other words are also looked into to extract that meaning. So this ambiguation is that process. Then sentence boundary detection, right? Very tricky. What is a sentence, guys? When do you define a sentence? Or let's say in this passage, how many sentences do you have? Yeah, what do you think? How many sentences are there? Yeah. Two sentences, okay. This could be one sentence, and this could be another sentence, okay. So how are we defining two? How are we defining that it is a sentence? Okay, three sentences, fine. Method of detecting where one sentence and another sentence begins. Separator, what is that separator? Full stop, right? Yeah. Period. Full stop. Very good. But look at this example. What about PM or AM? How many sentences are there here? Yeah. It is still one sentence only, right? If you take period as the sentence boundary, then it will say, what about P? This is one sentence. M, this is another sentence. Then you have or A, this is another sentence, and then again M, another sentence, which is wrong, right? So we cannot always take full stop as the indicator for a sentence, right? So this is also something you have to remember. Sentence boundary detection. We have a sentence annotator, which will try to identify the sentence considering all these things into picture, right? So always don't go with period as the sentence, full stop as the sentence boundary. Next, tokenization we have looked at, but there are different tokenizers that we will be looking out with. As an example, I'm giving the list here. Tweet tokenizer, this is specifically designed for working with tweets data, Twitter data. Multi-word expression, you can define two words together as one word. Okay, you are defining this, right? For example, United States. If you talk about tokenizer, United will be one word, States will be one word. You can define United and States as a single word for considering this as a single word in multi-word expression. When you're doing tokenization using this MWE tokenizer, it will treat United States as a single word. You can also add America here. USA, United States of America. All these words together will become one single word, like United Arab Emirates, right? UAE. So you would be able to define that. You will have control. Then regular expressions. In Python, we have a regular expression package, right? Which is also known as REGEX, regex. This is used to manipulate or work with strings data. So we have regular expression tokenizer, which can be used for tokenizing the words. And here we will simply use split function, very simple. White space tokenizer, based on space or tab or new line character, automatically the tokenization is done. Punctuation marks, right? Word punct tokenizer is basically splitting the word into tokens based on all these characters and digits. Veena, Raj, what about phrases? What do you mean by that, phrases? Can you give an example, Veena? What do you mean by that, phrases? It's just like your United Arab Emirates or United States of America. Your phrase, if you want to keep that as a single word, single token, then you have to upfront define it. And based on your definition, if that set of words are repeating in your textbook, in your data, which is known as corpus, then there's no problem. It will be treated as a single phrase only, single word only. Concept is same. Yeah, that is based on your any POS tagging, Nilesh. Some of the sarcasm can be captured based on your POS tagging, grammatical tagging. Yeah, Nilesh, got it? All right. Next, stemming. We have already discussed. There are multiple types of stemming here. We are looking at a couple of them. Regular expression stemma and Potter stemma. Right? Two or more different form of same word in different entities. Right? Same meaning will be there, but the form, representation of the word will be different. So in such case, we do stemming. For playing, we say play. We also have plays, players, played. Right? All these things will be there. But as I mentioned, the result that you are getting may not always be a dictionary word. Right? So that is basically something that you have to look out for stemming. And to handle this, we have lemmatization. In lemmatization, we basically look out for the words which are present in a predefined set of dictionaries. And this is nothing but a package. We upload the package which will get the dictionary also installed in our system. Right? And when we try to do the lemmatization, it looks into the keywords in the present in the dictionary, and if that word is present, then only we do the lemmatization, the splitting. Otherwise, the split is not done. This is not done. If the word is not present, it will not be done. But in stemming, we don't do that. We simply remove the follow-up word, the stem leaf word. Milind, yeah, we will have the recorded videos. I think you already have them. In recommended videos, these discussion points are already there. You can also go through them. but I think we will also reschedule the session. For now, I think we have the issue resolved. So we will see. If required, we will reschedule the session also. For performing all these cleaning, yes, Python libraries are used, Veena, that's correct. So is there extra cost in terms of performance? Of course, Shekhar, yes. Absolutely. See, rather than extra cost in processing, right, of the words, I would say it would depend on what kind of dictionary you're using, what kind of customization you're using, Shekhar. If you're using a default dictionary that is given by the WordNet lemmatizer, then probably not many words are predefined there. So even though you want to do stemming or lemmatization for that matter, sorry, you may not get a lot of lemmas. Words are not split because it's not there in the dictionary, right? So it depends on your requirement. You might want to customize the dictionary to enhance the size of the dictionary to cover more words, and more the words you have, better the splitting. Better the overall performance. When I say performance, I'm talking about the accuracies and all that, not just the speed. Nilesh, no, polarity, subjectivity, those things will come into the picture, Nilesh. Directly, as far as my knowledge is there is no package which deals with sarcasm, because it's again very, very random. So it does not follow a specific pattern for sarcasm, right? So you cannot identify, or you cannot have predefined packages for such kind of things. Is lemmatization same as text normalization? No, not really, Padmanabha. These are different things. Text normalization basically deals with different words with same meaning. But lemmatization deals with short form of the word, not different word altogether. Right? Stemming and lemmatization are similar, but stemming drawback is that the final result that you're getting after split, the word will not have meaning, dictionary meaning, sometimes. That would be a challenge in stemming, and that's where lemmatization comes into the picture. It all depends. Why you need this is a big question that you have to look out for. Do I need to perform stemming in the first place? If yes, then what kind of stemming is required? Do I have such words which do not have any dictionary meaning in the text data? If yes, then should I use lemmatization? If I use lemmatization, should I customize the dictionary? All these are cost-based analysis decisions that you have to make. Dictionary is nothing but bunch of words, Veena. That's it. You'll not be able to see the word, but if I have to show you a dictionary, it's nothing but a text file. .txt. And it will have the words defined. That's it. You can create your own custom dictionaries. You can open a text file, add the words. Simple. And then you define this for package. You upload to your package. So when package is referring to this text file, it knows that there are new words also added. All right. We also have singularization and pluralization. We also have language translations. We also discussed about stop word removal. All these are part of your data cleaning task fields. Language translation will come, especially when you're looking into blogs and those kind of things. People might use different words, right? So you may not understand. So you might want to bring all the text data into a single form of language. So in such cases, translation can be required. A number of such examples are there. Next. What we discussed till now are the various possibilities, various options that we have for cleaning, or I should say processing or pre-processing of your text data. Cleaning or pre-processing of your data, the data which is in text form. We also have feature engineering, right, or feature extraction, you can see. What is a feature here? In text data, can anyone tell what could be a feature? What is a feature, friends? Take a guess. You already know the answer. What is a feature? Ah, very good. Token. Feature is nothing but a word, which is nothing but a token. Right? So feature extraction, general features, and these general features will have all these additional values. Number of words. How many unique words are there in your text data? Right? Polarity. Polarity is the magnitude given to each word. Each word will carry magnitude for the sentiment. Right? And this is measured on a numeric scale. For example, 0 is neutral. Now, if I have to say positive sentiment and negative sentiment, the sentiment can go on the scale. It could be -1, -2, -3. So, sorry, my bad. +1, +2, +3 for the positive, -1, -2, -3 for negative. It can also be float somewhere here also. So there are predefined dictionary parsers, or we also call them as lexicons. These are nothing but dictionaries which are predefined with the magnitude for each word. There are certain set of words. We're not talking about all the English vocabulary. Certain set of words are predefined with magnitude. For example, if I say good, this is the standard example I love to give. The product is good. Let's say the phone. Phone is good. What is the sentiment? If I say the phone is good, what is the sentiment? It is positive. I could also say the phone is awesome. The phone is awesome. This is also a positive sentiment, right? Both are positive, but which would have more impact? The phone is good has more impact, or the phone is awesome has more impact? Awesome has more impact, right? So we want to quantify this effect, and using these predefined dictionaries, right, scientists have come up with the the magnitude here. For example, this may not be correct. Maybe positive is +2, awesome is +3, right? So this way we give predefined number. Similarly, we have subjectivity also, whether the word is subjective to that context, to that passage or not, right? So that is basically your various features or various values that you have for your feature. Then bag of words I've already shown you. Bag of words is basically the tokenization performed after cleaning. So this bag of words is a process which converts your unstructured text data to structured format. Right? It converts the data to structured format. That's your bag of words. All right. So as a process, what we're doing is we're taking the unstructured data, the raw text form, raw data. We do pre-processing here. We perform pre-processing, and this gives us the structured data. Right? Now this structured data is nothing but a key and value pair. It's nothing but a key and value pair. Key and value pair is nothing but a table representation where this header is nothing but key and the values are in the table like this. So this bag of words is a key value pair where the key is nothing but the keywords. These are nothing but the words. And the value that you have is the count of the word. If I have a specific keyword, how many times it is repeating is given in the count. That is the value which is captured in BOW, bag of words. Then we have normalization techniques here to address outliers. When you talk about count of the word, there may be certain set of words which are too frequently used, right? Which may not be required. You might want to clean them out, but even after cleaning, there might be certain words which are repeated many times. So to handle those words, right, we have this Zipf's law or TF-IDF weightage techniques, right? The count, frequency of any word, the count of any word is inversely proportional to the rank in the frequency table. It's inversely proportional. This is basically the Zipf's law concept, which says more the number of times the word is repeated, the rank of the word is less, because it is pretty obvious, right? The word is pretty obvious word. You don't need to have any importance given to that particular word. That is Zipf's law's condition. Okay, started up. No audio, no video also. Am I not? Oh, screen is okay, fine. I see that. I'm sharing the screen. Now it should be visible. Okay, audio is okay. Okay. Now the video is clear, right? Screen is visible. All right. Next, we also have very popular approach, which is called as TF-IDF. Shekhar has wonderful ideas. Huh? I like your way of thinking, Shekhar. Using NLP, we want to fill up the gaps, especially when we have internet issues. Now, this is another example which is very nice. If you praise too much, then yeah, it is inversely proportional to the frequency. So your wife would definitely say, don't praise me. I want to have higher rank. So good examples. All right, let's continue. So TF-IDF, another very popular technique which is applied for dealing with high frequency words, outliers. TF means term frequency. IDF means inverse document frequency, and this is basically the formula. In very simple terms, it talks about take the term frequency. Term frequency is nothing but the repetition of the word, count of the word in one document divided by document frequency. Overall repetitions of the word in different documents. Or you can say, in other words, I would say number of documents containing the word. Right? So let me say TF means proportion or percentage of the word present in a single document. Document frequency is the percentage of documents containing the word. Now we are dividing TF by DF to normalize the importance given to that word. For example, if I have Amazon reviews, I will have multiple reviews. Let's say I have 100 reviews, assume. In one review, a specific feature is being discussed heavily. Okay, in one review, a feature, let's say mobile battery, is being discussed. The customer is frustrated with the battery, or maybe he was having special interest in the battery. He was surprised to have seen such a battery. So either positive or negative, the number of times the word battery is repeated in the review is high. We're talking about count here. Okay, count is very high. This basically explains that for that particular customer, the feature battery is very important, right? But is the feature important in general for all the customers or for that product? Is that a special feature that we need to look into? Maybe, maybe not. If only one customer is speaking, then that feature may not be important for the product to be considered or for the manufacturer to be considered. It could be one of case. But if more reviews will include the word battery, then the overall popularity for the feature is increasing, right? So to address the outlier nature of this frequency, we multiply with 1 by this document frequency. This way we are saying, even though the single customer is representing that word too many times, for him it is very important, but for the overall set of customers it is not important, so I will reduce that impact. If you divide that big number with 1 by DF, magnitude comes down, right? So weightage is captured. That is your TF-IDF, right? And this is the formula. You can try and look into it. It basically uses log transformations and all that. And what we do basically is to generate this bag of words for all the words. from all the documents, and this is called as DTM or TDM, and this is the key value pair set that we are talking about, which includes the word and the count. You may look into individual documents, or you can include everything as a single corpus. I mean, the entire string data. Treat this as a single string and then look into the keyword and the total count. Right? So this way also we can try and look into the words. This is basically your DTM, because in the rows we are having documents, whereas in the columns we have the terms. And for a matrix, which is a two-dimensional object, we always talk about rows by columns. So that is DTM. It's a document term matrix, row by column matrix. If you transpose this, DTM, if you transpose, it becomes TDM. Rows becomes columns, columns becomes rows. It's just the arrangement of the data, and based on the arrangement, we call it as DTM or TDM. So this is basically your arrangement of unstructured data into structured format. Now, once I have the tokens, the keywords, and the frequency of those tokens, then telling stories using this structured information becomes very easy. And one of the visualization is called as word cloud. We take all those words and their frequencies, and based on the frequency, we arrange the words with respect to the font sizes. Higher the frequency, that means more number of times the word is repeated, more number of times, the font size is also high. Right? And then we can also do other feature extractions, which is basically your text similarity. Just some time back, I talked about ATS system, right? Automatic tracking system for resumes. So what we can do is we can extract the keywords tokens from resume. You do pre-processing, perform NER, and then obtain the tokens. Then the job description also perform the pre-processing and all that and extract the tokens here. Now look into the similarity based on these tokens. Right? Just look at the similarity. The similarity can be done using cosine similarity, Jaccard similarity, or something like that. This is cosine similarity. If I take, let's say, one resume, then all the words that are extracted from this one resume becomes one vector. Let's call that as A. Right? And job description, one job description becomes one vector. I'll call that as B. And we measure the similarity between A and B vectors using this formula, which is nothing but this. We can also use Jaccard's coefficient, or we can also use binary Euclidean distance or simple matching coefficient, any one of it. And we try to capture the similarity between the tokens of your resume and the job description. The resume which has the highest similarity can be given first rank. Right? Rank wise, you are sorting your resumes with a match to the job description, and then those shortlisted, probably first 20 or 100 resumes, will be contacted. Right? And word clouds we have already seen. There are other visualizations that we can do, which is dependency parse tree. And we also have named entities. It's like a tree structure which basically talks about dependencies between the phrases or words. Okay, it shows that I will do that probably tomorrow. We'll try to do this in code words as well. I'll pass one sentence and then I'll come up with the named entities diagram and also the dependency parse trees diagram as well. All right. So this is basically about the feature extraction. We'll talk about Spacey package probably tomorrow. And here we have something called as pipelines. Okay, so how many of you have attempted data engineering job roles? Recently, we have seen a lot of data engineering job opportunities. How many of you have taken up those interviews? Oh yes, Shekhar, it is always very good to learn about these skills because ultimately automated techniques are being used by people in dealing with shortlisting of the resumes. So yeah, definitely it helps. Even from the manual perspective also, if you understand how to deal with the text data, it becomes easy to tune your resume and get your resume shortlisted. Yeah, friends, data engineering. How many of you have attempted this data engineering job opportunities of late? Or let me ask you this, what do you understand by the term data engineering? What does this job role talk about? Yeah. Nobody? Yeah, am I audible? Okay, I see the responses now. Maintenance of database, not really. To deal with huge data, no. Very good, Shekhar. Okay, partially correct, Radhika. Not really. Raju, Akash. Veena Raju says data analyzing, cleaner processing, and coming up with behavior of data for ML. Okay, that's a very lengthy explanation, but yes. Very good answer. Short answer, Shalini. Crafting. Okay, very good. Not really, Padmanabha. No, that is a job of data scientists, not data engineers. Data analyzing also, no. Data could be. All right. So very simple. Data engineers are basically the people who construct pipelines. And to be specific, we say data pipelines. Why we need these data pipelines and what exactly means data pipeline? Data pipeline definition is, or to put it in a very simple explanation, if you have to derive insights, if you want to analyze the data and extract some meaningful information out of it, we need the data in a certain processed way, right? In certain arranged form. But the data which is coming from sources, it could be a file, it could be a database, it could be a primary data. These are all sources. And the data is in its raw format. Okay. Now, data engineers construct the pipelines. Pipelines are nothing but logical way of expressing the movement of data from one source, from one location, which is in a specific format, in raw format, to pre-process or format it and bring it to another location, which is in a proper format, in an arranged format, which can be used for processing. This is your destination. So we have source, we have destination, and data engineers are the people who are constructing these pipelines, which would move the data from one location to another location. And while the data is getting moved from this location to another location, we may also see the data is getting formatted here, right? It may be getting formatted. This is the job. This is the objective. But this pipeline should be a continuous pipeline. It should not break up. It should not have one-time access that you're talking about. It is a continuous flow of the data should be there, because deriving insights would not stop once. Analyzing the data would not stop once. It is a continuous job. So data scientists would come up here. This is where data scientists come up, and they implement machine learning algorithms or do descriptive analytics and derive some reports and all that, right? But before data scientists actually do the things, this is where data engineers come into picture. Yes, very good. It is nothing but in previous jargons, in olden days, before data science became so popular, this job role or this responsibilities were called as ETL role. ETL, job tasks. This is nothing but extract, transform, and we say load. Extract, transform, and load. ETL. Extracting the data from different sources, transforming it, formatting it, so that it comes into a specific form, and then we are loading it into a single data frame, you can say in Python, so that the data scientist can process it. Because the data might be residing in multiple sources, right? All the information is extracted, required information is extracted from different sources. So in order to handle this job role, initially data scientists were expected to do these things, but because now the data science job role also has evolved, right? The data scientist role has evolved. The expectations from data scientists has evolved. The job has been bifurcated, segmented, and the initial stage, this stage is the initial stage. This stage roles and responsibilities are called as data engineering roles and responsibilities. A separate name is given. And in order to accomplish this, what all various things you need to know? You need to know the sources. SQL, NoSQL. Then you can also talk about cloud sources. You can also talk about big data sources, right? Or your standalone files also. So various things, your source, right? Then you also need to know Python for doing processing, formatting, and all that. These are the two predominant things that you need to be aware of as a data engineer. And we're not looking at algorithms here, machine learning algorithms or data science skills, right? This is before you go to that stage. For example, if I talk about crisp DM, the first step is business understanding. This is generally done by senior executives, senior data scientists, right? Or project managers. The second one is data understanding, data collection, then data pre-processing. These are the jobs that data engineer should perform. Okay. Post which your fourth step, which is data mining, comes into the picture. So generally, data engineering job offers are given or rolled out to freshers or less experienced people. If you are having experience with technology, right, the tools and technology, then you may become an expert in this area. Okay, so this is how the industry is getting transformed now slowly. So data engineering is also becoming very crucial job role, and there are numerous tools that have now come up for defining the data flow here. This blue color chart that you're seeing, right, the data flow. N number of different tools are there which can be used for automating the data flow. And as part of data engineering, you will be learning about these tools. Hope this gives a good gist of things that you have to look out for, because data engineering job roles are bombarding in the market right now. Data engineering needed for no, anything, Radhika. It could be batch processing or it could be live streaming as well. Ultimately, your pipelines, right? These pipelines could be offline pipelines, that is your mode, or it could be live streaming pipelines also. As a data engineer, you need to make sure that this pipeline, this data flow does not break. Continuously, the data which is getting generated is passed to the next level. Okay, so this is the definition of pipelines. Now, if you are dealing with textual data for extracting or building an NLP application, then this is called as NLP pipeline. So what did we learn, friends, here? We struggled with internet issues and all that, but we have learned some bit, some concepts, right? So we learned about step one. Of course, data extraction we have not done, but we will have to get the data. So get the data. Post that, we pre-process the data, right? Then we also do tokenization, and then we draw extra insights. Now, if you have a text data getting generated, do you think it will get generated only once? For example, a simple example, Amazon. You have launched a product. Don't you want to continuously monitor the feedback of your customers? Yeah. You would want to, right? You definitely would want to look out for the continuous feedback. So that means as and how there is a review coming up, right? New review coming up. You want to take that review, that means extract the data, then pre-process it, tokenize it, and then maybe you're constructing word cloud. So this continuous flow should be there. You cannot directly take new review and construct a word cloud, right? It has to go through the set of process. So this is a pipeline. This process is called as a pipeline. Tokenization, stemming, feature extraction, model building, and we want to also save the model so that you can reuse that model. And in order to save the model, we will use joblib or pickle. These are the two libraries that can be used for dealing with your packages. Right? Yeah. Joblib and pickle will allow us to save the trained model. Okay, it is not that you simply load the model. You do the training of your machine learning algorithm. That model can be saved so that next time when new data is given, you can just use the trained model which has all these steps defined in it, will take that new data and give the result. So that's basically how you deal with your NLP pipeline. Okay, so next is web scraping. We'll look into that. Probably we'll take a 5 minutes break and then come back, friends. Or maybe we'll take 10 minutes break. Okay, we have been going continuously. So we'll take a short break, 10 minutes, and we'll come back. It's 5:06 in my watch. We will connect at 5:16 p.m. Okay, break until then. All right, friends, let's go for the break. Hey, hi friends. Am I audible? Yeah. Okay. Okay. We'll stop here, friends. We will stop here because again multiple challenges. My laptop backup is gone, um, and there is no power option here. So we will continue the discussion tomorrow. If required, we'll extend the session a little tomorrow because of the various gaps, breaks that we had got today. And we will also look into the hands-on tomorrow. Okay. Um, DTM and TDM, Swarna, you please remind me tomorrow. We will discuss on that. I'll explain that, especially when we are dealing with the use case. Okay, we'll do a hands-on, and that time we will discuss about it. The model we are talking here, is it in the algorithm-based model as part of ML? Why job typical is to save hard disks? So Veena, that also I'll show you tomorrow. Okay, we'll discuss about that as well. Hands-on would probably resolve your doubt with respect to job lib and pickle. Okay, yeah. So please, yeah, thank you so much for having the patience and continuing the session. Uh, do mark your attendance, friends. This is just to make sure that we also know how many people are actually interested to upskill yourself. So do mark your attendance, and tomorrow we will continue with the hands-on. All right. Thank you so much once again. See you guys tomorrow. Enjoy the rest of the evening, friends. Take care. Yeah, tomorrow would be even more exciting, Shaker and others. Yeah. No, Milind, as part of this session, we are not dealing with voice modeling. Speech is something we are not covering at this stage. We'll only look into the text. As part of deep learning, we have all those things also. The link is given, Nilesh, in the sticky pad in the chat window. You can see at the top. The link is given. You can mark your, click on that link and you can mark your, give your attendance there. Yeah, the Nathan has also mentioned that in the chat. Swarna, these are already there in the LMS for your data science course. The same presentations are already there in NLP module. Kumar, these sessions are already recorded, recommended videos. You might want to go through the recommended videos. Detailed discussions are there. In fact, other details are also there in that recommended videos. Okay, friends. Thank you all. Enjoy the rest of the evening. Good night. And see you guys tomorrow.